Students, I am Madhukar Sopil, Assistant Professor in Chemistry, Vijayanagara College Hospital, B.Sc University, Ballari. Now we are studying this part 4 under this thermodynamics. We are studying now for the B.Sc third sem is concerned, physical significance of entropy. First one, entropy is a measure of the disorder of the system. All spontaneous processes such as flow of heat from hot end to cold end of a conductor, flow of electricity from a point at a higher potential to a point at lower potential, etc. are accompanied by increase in the disorder of the system. That is, spontaneous processes are accompanied by increasing entropy as well as increase in the disorder of the system. Melting of solid or evaporation of a liquid is accompanied by increase of entropy. At the same time, it is known that a solid has a definite crystal lattice. You know this concept. Crystal lattice is a definite ordered element. That is, atoms in the case of crystal lattice, or ions in the case of crystal lattice, or molecules are arranged in a definite order. The order is much less in liquid and least in gas. That means in the case of gaseous molecules, the ordered element is not there. They are disordered system. And in the case of liquid, this order is little bit there. But in the case of solids, there is a different ordered element. So you can say that entropy is regarded as a measure of the disorder of the system. And the scientist Gibbs described entropy as a measure of the mixed-upness of a system. Second concept under this physical significance of entropy is entropy as a measure of probability. As seen above, this all spontaneous processes lead to increase in entropy and also to increase in disorder. A little consideration will show that when a process is spontaneous, it means that it proceeds from a less probable to a more probable state. Hence, there is a close relationship between entropy S and the thermodynamic probability W of the state of the system. This relationship is expressed by the scientist Boltzmann as according to the equation S is equal to K into L W log to the B.Sc W plus constant, where this K is called Boltzmann constant and K is equal to R by NA. Boltzmann constant value is R by NA. Given that R is gas constant, NA is either Avogadro number or a molecule. According to Planck, this constant value is taken as 0. Hence, S is equal to K into ln W or ln W. This equation is called Boltzmann entropy equation. A solid at absolute zero temperature is considered to be in a most ordered state. In this case, W is unity, that is W is equal to 1, then S0 is equal to K into small k into ln 1. This is ln, actually in the previous case you take this as ln. Value of this W is equal to 1, so ln W is become K ln 1 is equal to 0. Ln 1 value is also 0, so K into 0 is 0. This S0 is equal to 0. This is for the solids. That is in the case of solids, because of the most ordered state, the entropy is taken as 0. Hence, the entropy of crystalline solids at absolute zero temperature is taken as 0. So this is about the physical significance of an entropy. This is in the examination the last question for usually 4 marks or 2 marks. Next we have to study the free energy. There are two types of free energies are there. One is Helmholtz free energy, another one is Gibbs free energy. We study now this Helmholtz free energy first. Another name for Helmholtz free energy is work function. Definition of this Helmholtz free energy. This is defined as the difference between the internal energy U and the product of absolute temperature T and entropy of the system S. So it is denoted by A, and this A is equal to, according to this definition, A is equal to U minus T into S. Take this as equation number 1. Let A1, U1, S1 and A2, U2 and S2 are the thermodynamic functions for initial and final states at constant temperature T. Then for initial state, A1 is equal to U1 minus T into S1, take this as equation 2. And for final state, A2 is equal to U2 minus T into S2, take this as equation number 3. Then equation 3 minus equation 2 becomes A2 minus A1 is equal to U2 minus U1 minus T into S2 minus S1. A2 minus A1 is replaced by delta A, U2 minus U1 is replaced by delta U, and this difference of S2 minus S1 is taken as delta S. Then delta A is equal to delta U minus T to delta S. Take this as equation number 4. So it would about the difference now. Delta A, where this delta A is change in Helmholtz free energy, delta U is change in internal energy, delta S is change in entropy. But we know delta S change in entropy is equal to Q reversible divided by T, ratio of the quantity of heat absorbed by absolute temperature. Then T into delta S is equal to Q reversible. Substitute the value of T into delta S in equation 4 we get. In this equation T delta S is replaced by Q or EV. Therefore delta A is equal to delta U minus Q reversible. This is equation number 5. Next is from first law of thermodynamics. The equation is delta U is equal to Q reversible plus W reversible, or delta U minus Q reversible is equal to, in terms of work done, W reversible. But if work is done by the system, then it becomes delta U minus Q reversible is equal to minus W reversible. It is for the work done by the system. Therefore, the equation 5 becomes, this equation 5 becomes delta U minus Q reversible. This is completely replaced by minus W reversible. Therefore, delta A is equal to minus W reversible, or you can take this minus sign to the LHS, it becomes minus delta A is equal to W reversible. This is the expression for the Helmholtz free energy. This is equation number 6. Since process is carried out reversibly, W reversible represents maximum work. It is thus clear that decrease in the function, minus sign indicates decrease. Decrease in the function A, that is minus delta A, gives the maximum work that can be done by the system. Therefore, the function A is termed as the work function. It is expressed in terms of work, so it is called work function, and it was explained by the scientist Helmholtz. The another name is, it is also called Helmholtz free energy. Next free energy term is Gibbs free energy or Gibbs function. Definition of Gibbs free energy. Gibbs free energy is defined as the difference between the enthalpy H and the product of absolute temperature T and entropy of the system S. It is denoted by the letter G, and G is equal to, according to the definition, H minus Ts. Take this as equation 1. Let G1 H1 S1 and G2 H2 S2 are the thermodynamic functions for the initial and final states at constant temperature T. Then G1 is equal to H1 minus Ts1, equation 2, and G2 is equal to H2 minus Ts2, equation 3. To subtract this equation 3 with the 2, equation 3 minus equation 2, then G2 minus G1 is equal to H2 minus H1 minus T into S2 minus S1, or delta G is equal to delta H minus T into delta S. This is equation 4. This equation is called Gibbs equation. That means delta G means G2 minus G1, delta H means H2 minus H1, delta S means S2 minus S1. But at constant pressure P, delta H is equal to delta U plus P into delta V. Then put the value of delta H in the equation 4, we get delta G is equal to delta H is replaced by delta U plus P delta V. So delta G is equal to delta U plus P delta V minus T delta S. Or delta G is equal to, arrange the terms, delta U minus T delta S on one side plus T P into delta V. But we know that delta A is equal to, previously you have taken this equation, delta A means change in Helmholtz free energy is equal to delta U minus T into delta S. Then delta G is equal to, this whole term is replaced by delta A. So delta G is equal to delta A plus P into delta V. And also we know that delta A is equal to minus W reversible. Then delta Z is equal to minus W reversible, delta A plus by minus W reversible plus P into delta V. Multiply with minus 1 on both sides, we get minus delta Z is equal to minus getting plus. So W reversible minus into plus is minus P delta V. Take this as equation 5. The quantity P into delta V is the work done by the gas on expansion at constant external pressure P. Therefore, minus delta Z gives the maximum work obtainable from a system other than that due to change of volume at constant temperature and pressure. The work other than that due to change of volume is called net work. This total work is called net work. So therefore net work is equal to W minus P delta V. This is nothing but minus delta Z. Hence minus delta Z is a measure of the net work that can be obtained from a system at constant temperature and pressure. Temperature and pressure kept constant here. So pressure is, there is no delta term, constant, temperature is constant. The quantity G is called Gibbs free energy or simply free energy, or another name is Gibbs function. Thus minus delta Z is a measure of decreasing free energy. Therefore net work is equal to electrical work or the chemical work. Hello students, you followed this one. Thank you all.